In today's video, I'll be talking about fundamental guides for preparing the crop models. Before diving deeper, I wanted to simply go through this flowchart which shows the processes while developing the crop models. In order to make the crop models, first of all, we need to have like rationale or why we want to do it. Once we define why we want to do it, we need to identify the objectives. Whenever we want to model some things, we want to first have a clear idea why we want to do it, any rational objectives. After that, we will set the hypothesis. It could be one or two or three. If we have like many hypotheses, we want to make sure that they are connected with each other. Once we have objectives and hypotheses, we want to formulate our ideas in the mathematical form. That can be from the previous literature, or we can develop it based on our own experimentation. Once we have formulated our equations, we want to do some programming and write it in a code or in the computer, and we need to make sure that they are correctly programmed. The next step would be parameterization. I'll be talking about this later in like further detail. And finally, we evaluate the model and see whether our objectives were met. We should always go back to our objectives, whether our model made our objectives or not. If it made our objective, yes, we are done with the model. But if our objectives are not met, then we go back to the formulation and see whether there was something wrong with the formulation. And if there is something wrong with the formulation, we go back again and change the formula or the quantification. But if there is nothing wrong with the formula, we go back again and check whether our hypothesis makes sense or is it wrong. And if it is wrong, then we go back to the hypothesis and then rearrange the hypothesis. But if our hypothesis is not wrong, then we should again go back to the objectives and re-evaluate whether our objectives should be changed based on our results. If that's not the case, then model is not working, and in that case, we should give up. The key concept for the model development is we need to make sure that we have modest, clear, and really tractable objectives. Usually, the success in crop modeling is more likely when our objectives are really clear. This is according to Sinclair and Seligman, 1996. And the criteria for judging the acceptability of the model should be aligned with its objective. For example, when we want to predict the crop growth development, statistical criteria like coefficient of variation or correlation coefficient between the predicted and observed values can be used to assess the model performances. So we need to see the criteria for judging the acceptability of the model. Sometimes we may set the threshold. For example, if the correlation coefficient between observed and predicted values are 0.7 or higher, we can say that model predicted good and it is acceptable. Sometimes we may also say that coefficient of variation is if it's less than 15%, that is acceptable. So we should set this criteria. Other thing is, this is also called as like stopping rules. And other thing is like sub-model. Sometimes only one model may not be enough. In that case, we need to sub-model. Other critical assumption of the model development is usually crop model should be generally general. So models should be in general enough to apply in the various situations, but it's important to recognize that developing a universal crop model is not feasible. We cannot just make one crop model and use it for all the crops. It should be flexible and it should be grounded to the practical reality. Other thing is data availability. hypothesis should be chosen based on the availability of the observational data that can quantify and implement our assumptions. If data is not available, the hypothesis should be carefully reconsidered or modified. Practicality of the parameter is another critical assumption of the crop model development. The most useful models are those that rely on measurable and observable parameters. If there are really vague parameters, it may require calibration once the model is completed, and this can, increase the uncertainty or the complexity of the model. At the end, we want to evaluate the existing crop model. Existing crop model or hypothesis can be, valuable resources. So we may need to modify based on our observations.